All right, hello everybody, and welcome to the November 16th, 2021 iteration of the Kubernetes SIG-Windows community meeting. As always, these meetings are recorded and uploaded to YouTube, so be sure to adhere to the CNCF Code of Conduct. I'll start with some announcements. The code freeze for 1.23 is today. It's not really fixed when the release team will start to remove enhancements from the release, but it's usually kind of after business hours and whatever the time zone is for the release lead. So I think best to try and get those in as early as possible. I think most of the PRs that we want, the standalone PRs that we wanted for the perf improvements have been in. I believe the OS field and host process containers enhancements in, and it looks like the log viewer one is probably not going to make it. Is that correct, Aravind?
That is correct.
Yeah. All right, but that's all right. We'll keep working on it and just merge that right when 1.24 opens. That's probably the best thing. And then a couple of reminders. The docs PRs, if it's related to enhancement, they want those draft PRs open by this Thursday. I think I saw we have them for the host process containers and the OS field kept, so we should be good with that. And then the docs and release team would like those PRs to be reviewable or out of draft mode by November 23rd, which is next Tuesday. And then they want at least subject matter expert owners to review or approve by the following Tuesday. So let's just stay on top of those so we don't jeopardize any of the enhancements from the docs PR. And we also said that next week, I know it's a US holiday and things are kind of late. We said that if there's no agenda, then we'll just cancel the meeting by 5 p.m. So we'll take care of that. Does anybody have anything else they wanted to add to the agenda or announcements? If not, we can go into the agenda. Okay, first up is Jason, who wanted to do a demo of Tecton running on Windows. Do you want to introduce yourself? And then it should be open to sharing. If you want to share your screen. Let me stop sharing then for a minute. All right, go ahead.
Hi, let me start sharing. Is that working?
Yep.
Okay. Hi, so my name is Jason Hall. I work at Red Hat. I mainly work on Tecton and OpenShift pipelines. I am just now noticing a bug in this. I was supposed to present this 2 weeks ago. Pretend that says November 16th instead of actual today. I wanted to come and share the saga, the journey that Tecton went through to get working workloads on top of Windows. I think we came up with a novel approach to the problem. I'm not sure if it's a good approach to the problem, but it works. And so, and mainly I just wanted to sort of get some feedback from this group specifically, whether this was a good way to solve it, a bad way to solve it, if other people are having the same sort of problems, how we can all work together to do what we're trying to do together. I will be hopefully very quick because I know this is only half an hour and we already had some stuff. So Tecton is a CI/CD workflow orchestration platform on top of Kubernetes. It lets you build and test and deploy your code on Kubernetes, literally running as pods on the cluster. The idea behind it is, well, one of the ideas behind it is you should manage and secure your build infrastructure the same way you manage and secure your prod infrastructure. Jenkins is great and a lot of people use it, but it means you have like a Jenkins cluster that is differently secured and sometimes unsecured than your regular production serving infrastructure. And it would be nice to have the same expertise and the same tools available to both of those. Really briefly, Tecton is a bunch of stuff, has a bunch of sub-projects, but we have the main core one is called pipelines. We define a number of CRDs where one is tasks. Tasks execute a number of steps, run as containers, they run in order. Pipelines orchestrate tasks that execute in a DAG, so you can have two things deploy at the same time or run unit tests and scan an image at the same time. And when executed, tasks execute as pods on the cluster. That is as little information as that is the most information you need to know about Tecton to be able to understand what Tecton is for the context of this talk. So I mentioned that steps operate in in order inside the pod. This turns out to be a huge source of complexity for Tecton because Kubernetes really wants to run all these pods all at once, right? It wants to start them all and run them all. That's what it's there for. And Tecton wants to run, fetch, git repo, and then unit test, and then build a container image. It doesn't want to have all those run at the same time because that would be insane. So the way that we settled on a solution for this was to inject an entry point binary into every step and have that binary be responsible for sort of scheduling and controlling the order of these things. So when you specify a Tecton task run, it might be these steps: busybox, sleep 10 seconds, and then echo hello. And then the second one starts and says cat hello. If these both happened at the same time, utter chaos, nothing would work because cat hello would run before echo hello into hello. So the way we do this is by, when we take this task run, we generate a pod that does the same thing. It has one init container that has this entry point image that copies the binary out of that entry point image into a shared directory. And then we update each step's command to actually run that entry point and then, do all the rest. This is a huge oversimplification of what we're doing, but enough to get the idea across. The init container copies that entry point binary somewhere that's shared across all steps, and then the steps, that's how we inject it in there. We then, with that injected entry point, we have another set of shared volumes that basically say, watch for this file to exist before you start the actual command. After the first step is done, it writes run 1, second step waits for run 1 and writes run 2, et cetera, et cetera. And the good news is this mostly works. Most of the time, this actually works shockingly well. But back to Windows. So this has worked really well on Linux for 3 years or so, but we had some users who wanted to start running these on Windows containers. And the controller components all still can run on Linux, that's fine. But we need to run these pods on Windows. And the way that we were injecting entry points and using this entry point made that a little difficult. Among the challenges that we faced, we had some users who knew about Windows but didn't know anything about Tecton, and we had Tecton folks who know a lot about Tecton but none about Windows. Also, practically all of the people that were interested in Windows in this problem space were in Australia, and I am in New York. So we had also the latency issue of back and forth communication across the world. So we wanted to solve this similar to how we support multi-architecture today. Tecton works on AMD and ARM and PowerPC and S390X and potentially maybe others in the future. The way that we got that to work so easily was everything in Tecton is written in Go. The images are built using a tool called Co and are based on top of a distroless base image, the same one that Kubernetes uses. Co makes this really easy for us. When you co-publish or co-apply, or there's a number of things, essentially what it does is it does go build whatever you need, tar that up, and put it on top of that base image in the registry. It doesn't require a Docker daemon. It doesn't do anything in containers. It literally just shells out to go build, tars it, and pushes it to a registry. Because Go makes cross-compilation so easy with Go OS and Go Arch, or Goose and Gorch, I've started calling them. It's really fun. You should try it. Essentially, if your base image is a multi-platform image, you can just say for each platform in base image, Goose and Gorch, go build whatever, and then just more registry operations to assemble that into a multi-platform image. But Co couldn't build Windows images. I didn't know anything about Windows images. I'm sure this group knows at least something about Windows images. And that's part of the reason I'm here to talk to you to learn more. Co assumed Linux for everything, right? It assumed the tar layout that Linux container images wanted and didn't know anything about Windows. And so we had to build in Windows support for Co. This means adding that weird Hives directory that I still don't understand, having a magical incantation of PAX records header or something. Symlinks don't work the same, probably a dozen other things that I know nothing about yet. But with some help from BuildPax folks that have already sort of gone down these paths, we got Co to work with Windows, and it mostly works. We even have an end-to-end test running on GitHub Actions Windows Runner, which was nice. So Co will build for every OS and architecture provided by the base image, and distroless, which we use for our base image, only provides Linux. As far as I know, there are none in the world images that exist as suitable base images for both Linux stuff and Windows stuff. So we stitched one together. We wrote a simple script that sort of takes all of the images pointed to by distroless static non-root and all of the images pointed to by this Windows Nano server and stitch them together and push that and then use that as our base image. And after we do that, everything works. You can see here, this is a released image from the Tecton, the latest Tecton release. If you do green manifest, you can see there are Linux stuffs and Windows stuffs, and it mostly kind of works. And so now an updated image of our Venn diagram, there is, I think, exactly maybe one or maybe almost one person who understands both Windows and Tecton. That's me. I'm realizing now I shouldn't put myself in the list of people who understands Windows. We still have to sort of set expectations with users and potential clients and users of this. We still don't have experience running this. We don't have a CI testing for any of this in Tecton. So we went back and forth on the wording for it. Tecton doesn't officially support Windows. We provide images that allow Tecton workloads to run on Windows nodes. What you do with that is sort of up to you. We make no promises about, future breaking changes or compatibility or anything like that. But it works. I mean, the users who are looking for this, the friendly Australians that we talked to, they're, as far as I know, completely happy with this, which is really great. Next steps is get some CI involved and actually end-to-end test this sometimes. Write more or have more examples and more usage and more experience with running Windows nodes. And multi OSify all of our other components. We could run everything there. Everything's just Go. So if you wanted to, you could run the controller on Windows or webhook endpoints on Windows. This will probably involve improving Co for building Windows images. And actually, I see that Jamie is also on this call. Jamie and I talked yesterday about improving some of the underlying libraries to support building for Windows even better for all kinds of other things. So the sort of model that Co has of build a thing, slap it on top of an image is not unique to Co. Other things could just build a thing, slap it on top of an image, and should be Windows aware if they can be. The questions I bring to this group are, is this a model we should consider reusing outside of Tecton? Is it something that other people have encountered? How do they solve it? How have they tried to solve it and did it work? I'm not married to this solution. If there's a better way out there, I'm totally happy to use that instead, but I didn't really find one. And yeah, the question before, is Co's model one we can reuse outside of Co to build an executable and slap it on top of an image? All things I'd love to chat about and discuss either here or offline or in the Slack or anywhere. You can learn more about Tecton at tecton.dev. You can learn more about Co at github/google/co and distroless at distroless.dev. But yeah, other than that, I have nothing else to present. Thank you. Thanks.
I think that, yeah, the only other agenda item was Jay's. So I think we could probably talk about, spend some time discussing this. Sure. And kind of answering any of your questions. Yes, it's interesting. I guess my main question is, has anyone had this problem before? Whether or not they have needed this solution, whether I can't imagine I'm the first person to ever need an image built for both Linux and Windows. Yes, we have that problem quite a bit, and we actually have that solved a little bit differently in the Kubernetes or for all of the images that we use to run the EDE tests and the pause image itself. What we actually did, so Docker Build Kit now supports with Docker BuildX. We use that to build Windows images on Linux machines with builders, and it's pretty similar. If you do the output, if you specify the output as a type of registry and you have, I think, some experimental settings turned on, you can do something similar where we do exactly what you did, where they're mostly Go projects, so we cross build, and then we target the nano server image layer, stick the binaries that we need on there, update some environment variables like for paths, and then stick the binaries on there and then push that to the registry. And I think we had some of the same possibly challenges that you looked like you already solved, where the Windows image needs to have the metadata in the manifest, especially for the OS version. That I believe has been addressed with the Docker manifest tools. That's kind of what I'm the most familiar with here. And Claudio is actually, who's on the call, pioneered most of that work.
Okay.
Yeah,
So
there have been some updates to Docker build-X since then, and you can simply just Docker manifest -des OS version as well to Docker images. So we don't have to hack around that ourselves. So adding OS versions to the manifest images is directly supported by Docker as well. As for the other challenges, I have seen some of them
what
as
happened to
well.
Claude?
Oh, I'm sorry, what? Am I on mute? I don't know.
Wait,
I
is
can
it
hear you.
my audio went out?
I don't know. Is
I can
mine
hear Claudio,
still
I can hear Jay say like 2 words and then it gets muted again.
strange? So I'll go again then. I was mentioning that Docker manifest finder supports adding OS versions to images as well. The workaround for that previously, but we don't have to rely on that anymore. And indeed, we do use Docker build-X to basically slap on binaries and other things on top of Windows images, as you do. But I am curious about different things. When you mentioned that co slaps on the binaries on top of the image and so on and so forth, does co require to pull the image first and then
No.
add the? It doesn't, huh?
No, so
That's-
it pulls the manifest to know what, you know, the digest of each of those images, the constituent manifest in the list are, but then it just does registry operation. It never pulls the blob. It never has to like pull, you know, the full contents of the layer underneath it, because it doesn't care what's in the layer underneath it. It's just slapping something on top. So it's all registry operations, just to pull manifests, modify manifests, push manifests. It never touches blobs.
Yeah, that's, in my opinion, that's fantastic, because some Windows images are quite huge. For example, the Windows Server Core images, they are 2 GB in size, compressed. If you compress that, it's going to be even larger. And if you have to build for quite a few different images, that's going to take a while. So I think that's very nicely done.
Are you right? I didn't have a demo, but I could show you a demo of building this, and it takes, you know, maybe 5 minutes to do all of the builds for all of the platforms and push them all. In the images that you're talking about, are they only running Go build on something, or are they doing other stuff? Do they need stuff from the base layers?
So the way we've done those images, we built some multi-stage Docker files. Basically, it has a Linux stage in which we prepare stuff like curling some packages, untarring them, unzipping them, compiling binaries, and so on and so forth. And then we just copy them over to the Windows stage.
Okay.
I think we do also copy, we do have a kind of an image helper that we have that caches all of the PowerShell like offline install files, and then so from another Windows container, and then we do copy those onto, I think there's an install list setup that we do into Nano Server also.
Yeah.
James, got your hand up.
Yeah, a few slides back, you mentioned something about sharing the base image. Would you expand upon what you meant there?
This one?
Yeah.
Oh, one forward.
Or I think it was this one or the one right before it.
Sure.
Okay, so
maybe this one.
Yeah, it might have been this one. So I guess could you talk a little bit more about this, because I didn't think I caught exactly what you were saying.
Yeah. So Co by default, when you try to build an image, you say base it on this thing, and if it's a multi-arch image or manifest list, it will figure out what all the platforms of the things underneath it are, run go build with Boots and Gorch, and then slap the things on top of those things. That works fine for distroless, or when there's sort of one image that contains all of the base stuff you need and care about. But we didn't, or I didn't find an image that was a suitable sort of distroless plus Windows stuff. So I built it's a tiny, I think 100-line Go script that just pulls these image manifests, makes sure that there aren't any conflicts in the platforms, and then stitches them together and pushes it to a registry. I think this is essentially what Docker manifest stuff could do or does do. And maybe I can get rid of all of this by just running Docker manifests, stitch together these things. Yeah, I would be totally fine removing this as a step.
So this was the part to be able to patch the OS versions into the manifests.
Yeah, so currently it only stitches together these two images. If there were, distroless provides all the Linux-based images, and if there were 5 Windows-based images I needed to stitch together with different OS versions, this is the tool that would do that. That would like make sure that there weren't conflicts, or technically you can build on top of an image that provides 2 things with the duplicate platform, but I don't know that anybody knows what would happen when you go to run it. So don't, please. But yeah, this is an area that either this tool will become more sophisticated and stitch together more images, or it will be completely erased and replaced with a Docker manifest stuff. Sort of similar to, it sounds like what you all are doing with your base image.
Yeah, it is similar. Our base images are kind of inverted. Most of them have like one Linux flavor and then multiple Windows flavors, like Windows Server 2019 and Windows Server 2022, because those are generally not compatible with each other, but kind of very similar.
Yeah. Ibrahim has his hand up as well.
Yeah, Ibrahim, did you want to?
Yeah, so I guess, yeah, we had the same case experience at Google as well. I think one solution, as Mark was mentioning, is using build-kit or build-x. So we have a Docker file where we inject the base, then we build those images and have one step to create the manifest. But the other thing we always hate is when we actually want to build an image that needs to be built on a Windows OS. So did you have any experience of actually using real Windows nodes in the cluster where these build steps can be scheduled?
Yeah.
And then,
go ahead. Sorry.
Mainly for this scenario. So because the other one, I think it's using build-kit or build-x will mostly get it with some hacks if you are not actually having any run commands or something that requires the operating system.
Yeah, so none of this is ever built on a Windows node. This is all run from, I mean, in theory, it could be co-runs on Windows if you want to, but all of our developers build on Linux, and our CI all runs on Linux, including our release process. So Windows nodes are never involved in the process. One thing I wanted to, so BuildX can do this, but I think if you are using BuildX and Docker files to express like a bunch of scaffolding to build up an environment where you end up running go build, like that is hugely wasteful of resources and time. You have to pull the whole base image to get, like go build doesn't care what's in the rest of that image underneath it, but Docker, BuildX and Docker files don't know that. So it's going to say, oh, before you can run go build, I have to like fully hydrate the whole OS, system for you underneath you. And then you just say, well, I didn't need any of that, go build. So that's effectively what code is trying to do, is say like, if we can assume you don't care what's underneath you, which is again, not every case, but in our case, we know we don't care what's underneath us. Just run go build, do a cross compilation from Linux if you can, or cross compilation works no matter what the host OS is. Do all of that and then just append it to that image up in the registry and never have to pull that stuff. So like BuildX will work, and like it sounds like BuildX is totally working for you. I'm not trying to advocate like change your whole build process, but I think if you know you don't need it, if you know you don't care about what's underneath you, you don't have to pull that. But BuildX isn't smart enough to know that, and I don't think there's any way to tell BuildX like don't pull that 3 gig image, just run go build and put the thing on top of it, it's going to go and pull that 3 gig image because it thinks it needs to.
Yeah, I totally see the benefit of this. I was just curious because the other problem is something that we face with a lot of customers. Even some cases, they don't care about Linux, but as others were mentioning, with Windows, you have different flavors. So someone will need to build a multi-arc image that supports SAC, LTSC, and the new Windows 22. And they look for some kind of a way that can orchestrate this. So that's why I was curious if you came across this problem or tried to figure a way that can actually build using Docker on different Windows nodes and then combine and stitch it together.
No, that's an area like I still don't know anything about the many different flavors and varieties and OS versions of Windows stuff. If Go cross compilation works across on top of those, then I never need to know, right? I hopefully never will learn. But that's only because we know we don't care about what's underneath us. We're just going to slap something on top.
I agree.
Yeah, Jamie.
Thanks.
I'm gonna say I'm gonna drop real quick.
Oh,
I need
sorry.
to go to SIG node, but this is really interesting. Feel free to carry on this conversation, or we can bring this up again. Jay, I'm gonna make you host. Just remember to stop the recording before you go to the pairing.
Node. Okay, at SIG node, by the way, can you ask them why they have their videos being published, but I don't think us or SIG Network are publishing anymore. So if you talk to them, see if they're doing something better than we're doing for our YouTube recordings.
I might just be behind on that. I usually do that.
Okay. All right, cool.
That's my bad.
I'm fine with community. I'll link you. Okay.
So I stumbled across Co like a couple weeks ago. We were already using Crane to pull images and things on Linux for Windows and to create and to package up, air gap tarballs and stuff like that. So I got really interested in this because we use drone currently right now for our CI, and we couldn't build 2022 until there was 2022 images in AWS and in Azure. Right.
Yeah.
So it took AWS a little while to get an AWS base image published. But if we were using something like Co to do what we package up, then we could have built 2022 on Linux way before and not have to wait on anybody. So that's where my big interest is the fact that we can just streamline our workflow. We don't have to worry about making Windows runners. We don't have to worry about, like, drone currently doesn't support 2022. Well, we don't even have to think about drone needing to support 2022 with a runner because we can do it all on Linux. So just for other people that might have questions, like that's my big interest in it and our interest in general, because we package a lot of things inside of containers and like use that to ship software. And we were already using Crane to pull and extract stuff out. So we were already doing that by default. So, I found Co, and Jason and I talked already this week, but I'm all in personally on this, and I think we're going to be trying to move some of our stuff to using more of this approach instead of using like BuildX, just because it's a little bit more complex to set up. So,
right, yeah, that's another good reason. Aside from having to pull the whole base image, that whole base image has to exist and be runnable in your environment or whatever. Like, Co doesn't care. Co's just gonna go build and then registry stuff on top of it. So yeah, I have nothing after this. I'm completely happy to take more questions or talk any more about this. You can also hit me up offline on Slack or Twitter or anything else.
Jason, this is cool. We always do this SIG Windows pairing hack essential thing like at this time, and do you want to drive and just like show us stuff? Like it doesn't have to be a demo. It just like if you could just show us stuff, all tips and update the reading.
Hey Jay, sure. Your audio is skipping, like duplicating or something.
Oh, okay. I'll fix that.
Yeah, I mean, with the caveat that I have absolutely nothing prepared, I'm totally willing to open browser tabs and poke around and show whatever anybody is interested in.
That's how we usually do it. So
perfect.
I do have a couple of
questions
remaining. just to make sure, when you build the image with core, it does inherit the OS image version for Windows images, right?
Yeah. Actually, I can show in the slides again.
From what you showed us there was from Combine, which of course it took the
Right. So
whole manifest info.
right. So it's Combine. This actually demonstrates two things. One is that Combine is able to copy over the OS version stuff from the stuff it combined, that it doesn't drop it. And that Co built this image. That Co, when it builds it, doesn't drop that on its way through. So yeah, both of those, if Combine took multiple multiple things to stitch together, which is a relatively easy change, this could be 10 different OS versions of this base image, and then this would show up with 10 different OS versions. And to Jamie's point, like this can also be Windows versions that don't exist, that aren't runnable yet, or aren't rolled out on AWS or something. Yeah. I don't know what people are interested in seeing, but I can show you the pull request to Co that added Windows support, because I think it's one of those PRs that takes a very long time to work, but at the end of it is only a couple hundred lines of actual changes. One of those really, really fun PRs where choosing what the right 100 lines are was the hard part.
So you had mentioned stuff with the Hive and those files. Did you manipulate those, or what were you doing with those?
Yeah, so I can actually go through and show you in here. So this is another step, does the go build and just says like, here is the path to the binary that was built. And then this function just tars it up into a tar file. Before we were just doing like tar add directories, just adds that binary to the thing. And after this, we have to, if we're building for Windows, if the base image platform is Windows, we create empty directories for hives and files, and do this thing, which I would love for somebody who understands what this is to tell me what it means, because it's this eldritch horror of screaming random opaque string. But this was necessary to get it to run on Windows. I don't know why. And then what it does is, we skip some links. Yeah, I guess that's it. I guess that's mainly what we do is when we are tarring the file to put it into that new layer, we have to create these empty directories. We don't put anything into hives. We don't put anything else into files except for the binary that we write in this hidden section. We write, this is the binary, and then copy the binary file into it. So the actual change for Windows here was relatively small, was just like, if we think we're building for a window, if we're building a Windows layer, create these empty paths. I guess hives is the only one that ends up empty. We create files in CoApp and then set this magic header.
I wonder if the hives, and maybe Claudio knows this, but like, so if you pull down an image and you extract it and look at it, there's the hive files. They're just a bunch of registry files. Those come from the base image. So I wonder if, like, I wonder how that interacts with the way, because you're not actually pulling the image, and so you're not uploading those files.
Right. So my completely dumb understanding of what hives is it's like being able to layer registry tweaking, right? So this layer doesn't need to do any tweaks. It in theory shouldn't have a hives directory at all, but for some reason it's required. So it's just going to take whatever's in that base, the same way that like if there was a file at path foo_bar_baz.txt, like this layer doesn't care. It just needs to say on top of that layer, add this other file. So it's the same with hives, as I understand it. And luckily, we don't have to look into what the base image provides by way of those hives. We just add what we want to add, which is nothing, in our empty hives directory. I don't know if that was a good explanation.
How's my audio now? Doing a quick sound check.
Still very bad.
It might be worse, actually.
Keep going.
Yeah, so that's, I mean, that's the main stuff we do. Co also does this thing where if you have a path in your repository or in your local workspace that is /codata or like a codata directory, then it will also tar up everything in that directory and make it available as a layer in the file or in the final image. This is just doing that for Windows. It's the same sort of thing. So we're creating a new layer. We have to have this Hives thing there. But other than that, it's other, I guess, what else is interesting? We have, if the platform is Windows, the entry point is C:\coap file name instead of whatever, and we update the path to be C:, whatever.
I mean, it's not mandatory for Windows images, but yeah.
Oh, would it have worked if it was?
It works, yeah. For example, even on Docker container images or containerd containers, you can just have the entry point //.entry. It doesn't even have to have the .exe
Oh, great
extension, as far as I know. Yeah.
Fantastic. I will delete these lines of code after this meeting, because that would be great to have fewer and fewer things.
You do have to be careful with the .exe thing. We found that with the host process containers work. So just there's special edge cases where you do need to have the exe. But,
okay, yeah, sure. I mean, the nice thing also about this is that this induced us to have end-to-end tests that run on Windows. So we hopefully won't regress on anything, hopefully. But yeah, the rest of this is pretty, standard and easy. I don't think there's actually that much to it. It was mainly, fumbling around in the dark to figure out what this was. I straight up copied this from build packs. I still don't understand what it is. If anyone else does, I'm all ears. But the rest of this is like, oh, you need an empty Hives directory. You need this pack setter. I can do.
Isn't that special string? I don't know, James, you might know this. Isn't that special string? I think it's getting translated to one of those well-known SIDs.
yes,
Is that what's happening there?
That looks like a base 64 encoded SID string. Yeah.
Yeah, that's what I'm
Which-
thinking is happening.
It should be container manager / container user or something like that. That's not technically base 64. That's a security descriptor. So those letters and things mean something, supposedly. I did some research last night, and it's complex.
Well, the SID stuff has got a special format, but those A, B, D things isn't SID format. So,
Okay.
Yeah, but I assume that's what it translates to somehow, is that translates into a SID format, which would have all the security descriptors. And it's, I guess, I don't know. I don't know the exacts on why you need to have it, but I can ask around a little bit.
Yeah, I mean, everything works. The good news is everything works. The bad news is I have no idea if I am like, invoking some terrible, belly of the beast terror by using this string, right? Like, if am I just making everything executable by default? I have no idea. But if anybody has a lead, I'm all ears.
I have pasted in chat a link to a Windows Docker file in which we don't even use .exe at the end of it. This is one example.
Yeah,
Great.
and when we took this exact image and ran it as a host process, it failed. But I think Danny's made some changes to the way that's handled. There's like something deep in one of the syscalls that you have to turn on to be able to handle that situation.
And
yeah.
You mentioned that you had some issues with symlinks, right?
Yeah, I actually don't remember exactly what they were. Oh, in the code data thing that I mentioned before, it's very common for people to put in their code data directory a symlink to like, .git/head, so that in your image you always have a file that tells you what the git commit was. This is sort of a lazy hacky way of doing the LD flags, inject my git commit into there, which I think probably will stop recommending. But So very, very often in code data, you will see symlinks, and I hit some issue with it and was near the end of being able to get this merged. And so I just gave up and did a to-do. But if I, get enough activation energy, I'll go try it again and see what happened. But there was some issue with chasing symlinks and putting symlinks into this that, frankly, I don't remember what the issue was. But yeah.
Because technically, you can add symlinks to those tar files and submit them. I mean, that's how Docker buildx does it as well. The only issue with Docker buildx is that it prepends files / to every single symlink target, which can break the symlink itself. You'd have something like files /c : which makes no sense.
Right. Maybe that was the issue, that I was like canonicalizing the path and then trying to add files to it, and that made it nonsense. But yeah, I mean, this is a relatively small thing in the grand scheme of things, and Tecton doesn't even use that really that much, so at least on Windows. So I was more than happy to just add a to-do instead. I can also share a work in progress to. So Co is built on top of a library called Go Container Registry, which does most of the registry operations, like just append a layer to this manifest or whatever, and then push it. And so this is an attempt to, and this repository also comes with a command called crane to append, basically do that in the CLI. So you can say, like, take this tar file, add it to this base image, push it to here. This is necessary to select the Windows image out of here, but this code path didn't do the Windowsification stuff that Co did. Co had the logic for it, not Go Container Registry. So this is an attempt to sort of move that up in the dependency tree and do that itself. So we have mutate a layer that is just a regular tar file. In the example, here I can show you the example again. In the example, this is a tar file that I created on Linux, so it's Linux formatted and everything. This just takes that layer tar and does the same thing, adds an empty hives, prepends files, and sets the PAX records to that Eldritch Horror string I mentioned before. So basically, this is like moving this logic up and up and up into this package so that you can do crane append any tar file to the top of an image. This could be useful to you if you could simulate what Co does by basically doing go build, tar that binary, and then go run, you would just do crane append on top of this Windows image. That tar file, you could effectively do what Co does without Co. The interesting thing about this is you can do this for languages that aren't Go. Anything that can cross-compile. If you can do cross-compilation of .NET binaries, cross-compilation of Python, cross-compilation of anything else, you should be able to extend this to do that with anything. That's what Jamie and I were talking about yesterday.
Okay.
So
minor question. Technically speaking, that nanoserver image is actually a manifest list which contains both AMD64 and ARM64 images, I think.
Yeah.
I think you're using that selector. Okay. But then what if you have an image which has in its manifest list multiple Windows AMD64 images for different OS versions?
Yeah, excellent question. Jamie actually also recently fixed this issue where OS version.
Yeah, you can now pass the OS version to crane pull and it will pull.
Oh, okay. Mm-hmm.
So you would just, for this example, you would do crane append platform AMD64 and OS version, this one, or whatever. Yeah, this was just merged last week. So these two together would basically give you that ability. I haven't tested it, but it should give you that ability.
It works. We're already using it. So.
Okay, great. See, perfect. It's already live and broad.
Nice.
So yeah, I don't know. I mean, yeah, I have no direction, but I'm more than happy to keep vamping and talking about this stuff. If people have questions, I can answer them, take them. It sounds like this is at least a novel way of approaching this, and maybe even a useful one. So, you know, feel free to keep this in mind in the future if you're hitting problems like this. One of the real like tenets of Co is if you don't care about having the whole operating system available to you when you build stuff, like why are you pulling all these images, pulling all these layers down just to hydrate an OS around you that you just run go build inside of and then destroy? Like, you should just go build in your regular environment where we assume it has no side effects. We assume it can cross compile. We can, you know, it's pretty fast. It shares your build cache, a lot of good stuff. And then just take that and slap it on top of an image using registry operations. It's pretty nice.
Yeah, and I'm going to be testing this with like .NET and doing framework dependent and just using one of the runtime base layers to see if I can get that to work, because that would be pretty cool.
Yeah. So one thing, because Go binaries are static and don't care about what's underneath them, we tend to use distroless static as our base image, which is very, very small and has almost nothing in it. If you do care or do need something from your base image, you can absolutely do that. But Co is you know, like, you know, super optimized for Go that doesn't care about it, so we don't tend to worry about it. But to Jamie's point, you could absolutely build something that does need DLLs from somewhere else, so long as the base image you're building on top of has those. It should be fine.
Yeah, we usually cache those DLLs into different Linux-based images, or rather Scratch-based images. And we just pull that image, which will be something like 1 megabyte in size.
So you're interesting. So you're basically, you're taking a Scratch image and putting some DLLs in it, and then kind of appending on top of that, right?
Yeah. But
Nice.
for example, we do have Windows Server Core cache, which does exactly this thing, as I mentioned. There are certain applications that require some DLLs, like NetAPI32 DLL, in order to run some HTTP servers.
Mhm.
Those are not available in Nano Server; they are available on Server Core, and the solution would be to just copying them over to Nano Server. But again, pulling the entire Server Core image would be extremely painful. So we just cached those DLLs into an image, a Scratch image, and we use those in
Interesting.
later builds.
Cool. Yeah, I mean, I still know almost nothing about Windows, but the more I learn about it, the more I think like this model is really good, just because your base images are so huge and you probably don't need them for most of the stuff you're doing. Yeah, I think it can be a real benefit.
Yeah.
And even just being able to like Tecton's release process was hardly changed throughout this. All we needed to do was add that combined step and then build on top of it. And you know, our release infrastructure still runs Linux, doesn't need to care about Windows. We'll eventually need to add like Windows nodes for CI testing this stuff, just to be able to make sure we're not regressing on Windows in some way. But it was super nice to be able to just do like multi-arch and multi-OS base image stuff. It was super nice. Yeah, I guess hit me up on Slack or anywhere if you have questions or want any pointers to any of this stuff later. I'll add the slides to the agenda. I'll link to the slides to the agenda if anyone's curious. But yeah, thanks a lot, everyone. This has been really interesting.
I assume we find you in the SIG-Windows Slack as well.
Yeah, I think I'm in there. I'm pretty sure I'm in there. If not, at Jason Hall, you should be able to find me.
Great. Sounds amazing. Thanks for the information and presentation.
Thank you. Thanks for having me. Talk to you later, everyone.
Awesome. Thank you.
No, since I'm having audio issues, I gotta fix that.
Jay, do you want to stop the recording at this point?